Good evening, sir. I am Pushpita Sri from the Department of Computer Science Engineering. Today, my topic is about chain growth and step growth polymerization. Introduction to polymerization. Polymerization is the process of creating polymers from monomers. It plays a crucial role in the production of a material used in everyday life. Understanding the types of polymerization helps in selecting the right process for specific applications. Types of polymerization. There are two primary types of polymerization: chain growth and step growth, and it is also called as addition polymerization and condensation polymerization. Each type has distinct mechanisms and characteristics. The choice of polymerization method affects the properties of resulting polymer. Polymerization is two types: step growth and chain growth. In step growth, there are again classified into two types: poly addition and poly condensation. And chain growth is classified into three: radical, ionic, and coordinative polymerization. In ionic polymerization, there are two: cationic and anionic. Chain growth polymerization. Chain growth polymerization involves the successive addition of monomers to an active site. It typically requires an initiator to start the reaction that can proceed rapidly. Examples of chain growth polymers include polyethylene and polyester. Mechanism of chain growth polymerization. The process generally includes initiation, propagation, and termination stages. Initiation generates free radicals or ion that begins the polymerization process. The growth of the polymer chain occurs through the addition of monomers to the active site. Here is an example of chain growth with initiation, propagation, and termination. Characteristics of chain growth polymers. Chain growth polymers often exhibit a lower molecule weight distribution. They have a high degree of control over a polymer architecture and functionality. The reaction rate can be very fast, leading to high production efficiency. Next, step growth polymerization. Step growth polymerization occurs when any two reactive species combine to form large molecules. This method does not acquire a chain reaction and can involve multifunctional monomers. Example of chain growth polymers includes polyesters and polyamides. Mechanism of step growth polymerization. The reaction which involves the formation of bond between monomers through condensation or addition. It occurs in a series of reactions where the degree of polymerization increases gradually. The growth can continue until all the functional growths are consumed or the reaction is terminated. Here is one example of nylon 6,6. Characteristics of step growth polymers. Step growth polymers typically shows a broader molecular weight distribution compared to chain growth polymers. The properties that can be turned by the choice of monomers and reactions of condensation. They can often require a longer reactions times to achieve high molecular weights. Here example of condensation polymerization is polyester and another is polyamide. Comparison of chain and step growth polymerization. Chain growth polymerization is faster and produces molecules with specific architectures. Step growth polymerization requires a higher degree of functionalization and leads to a wide range of properties. Understanding these differences is a crucial for materials development and application. A chain growth polymer is the formation of a polymer from unsaturated polymer, and a step growth polymer is the formation of a polymer from bifunctional polymer or a multifunctional polymer. Conclusion. Both chain growth and step growth polymerization plays a virtual role in the material science. The choice between them depends upon the desired properties and applications of the polymers. Ongoing research continues to enhance the optimizing both polymerization methods. Thank you for giving this wonderful opportunity.